Welcome back, ladies and gentlemen. In these videos, we'll be looking at chemical names and formulas and how to write one from the other. First off, let's look at ionic compounds. And so we need to know how to name ions so that we can then name ionic compounds. Monatomic ions are the easiest ones. That is where you have one atom of an element that has formed an ion. If it is positive in charge, then it is a cation, and those typically form from the metals. So the ones we will focus on most frequently will be 1A, 2A, and 3A metals. So lithium through francium in the first column, beryllium through radium in the second column, and aluminum we're going to focus on most in the third column. The reason we're focusing on these specifically, while there are other metals in between them and below aluminum in the third column, those typically make more than one type of ion in charge. So while these will only have one that they can each make. First column will be +1, second column +2, and aluminum will be +3. Now when you name them, you simply list out the name of the original element, but to say that it's an ion, you put ion after it. So for example, lithium, when it has lost one electron, it becomes the lithium ion. Sodium is then called the sodium ion after it loses an electron. It's that simple. Anions work a little differently. They are formed when you gain electrons in the atom, so that's not going to be metals. It's the nonmetals like the ones you see listed at the top of this chart. So 5A, 6A, and 7A, those are all going to form anions. Now 5A, as you should recall, forms a -3, 6A forms a -2, and 7A forms a -1. They do not just have ion added to the end of their name, they in fact have the end of their name changed. So nitrogen has the ending changed to IDE and becomes nitride. IDE, taking the place of the ending of an element name, indicates that it's an anion with a negative charge. So below nitride, you would get phosphide from phosphorus and arsenide from arsenic. Oxygen becomes oxide, and so on and so forth. Now at the bottom of this, you see the chromium and all of the others down here that are listed out. Those are some of the transition metals that I referenced that will make more than one type of ion. Okay, they will pretty much all do a +2. They will generally also do either +1, +3, or +4. But virtually all of the transition metals do at least a +2, and you don't need to memorize those, but I would like you to know that that's what's going on. So the elements that you should know that form just one specific ion, and it's always the same, here they are. You should have these already listed on your periodic table, and you should be able to keep track of them. Now, back to those pesky transition metals, because they can do more than one thing. Let's take a closer look. In fact, you will find these in many things around you all the time. When they do form different ions, that changes some of their properties. If you think back to when we looked previously at the different colors that you could see coming from the line spectra of the elements, then you remember that each element had its own unique set of colors that it would give off of those spectra. Well, those were due to the number of electrons bouncing between the different energy levels. If you change the number of electrons present, you'll change which line spectra are given off. So sometimes you can have the same element in two different ionization states, creating different colors. And so specific ions of individual elements are used to make colors in things such as paints or in other solutions. So here you can see cobalt, chromium, iron, nickel, and manganese, +3 for each except the manganese, which is a +2. If you had their other charged states, then they would be different colors than these specific colors you see here. Each element will have a certain color for each ion, and those will generally change when it goes from one to another. You don't need to memorize any of the colors, but you should know that that's what's happening, and that if you were to change to a new ionic state by adding or removing electrons, it would change the color of the solution. Now the transition metals can be named using the old classical naming system or the newer stock system. So the old classical names you see listed on the right hand side, these names are generally hundreds or thousands of years old and existed before they even knew what an electron was. Okay? So they didn't know that they were changing electrons, they just knew that copper came in more than one type. And so if it was copper that we now know is the +1, they called it the cuprous. The +2 they called cupric, and they didn't know that they were +1 and +2. They did know that they reacted a little bit differently with things, but they didn't know why. They just thought it was something inherent in the different types of copper. They knew there were two types of iron. They called them ferrous and ferric. Now, you don't need to memorize these classical names. I would like you to notice, as you glance through here, that the ic form on each of them has one more on its charge than the OUS form. The us is the less charged, the ic is the higher charge. And when you look at the stock names, those are easy to relate to the symbol because they tell you, with the Roman numeral, exactly what charge is present. So copper 1 is the copper +1. Copper 2 is the copper +2. Iron 2 is iron 2+, and iron 3 is iron 3+. So the stock name tells you the charge on the symbol. And if you know the charge on the symbol, then you just put that as the Roman numeral after the name of the metal when you write the stock name. The only one here that might be confusing to you is the mercury 1 ion, mercurous. So even though it has mercury with a +2 charge, it says it's mercury 1 because there are two mercury atoms present. So each mercury atom in that has one ion attached. This is what is called a polyatomic ion. Mercury 1 only appears as a polyatomic. We'll get into polyatomics in more detail later, but suffice to say, they are just the case where you have multiple atoms bonded together that act like a single atomic ion, so a monoatomic ion. I would like you to take a moment here and practice writing out the symbol with the charge present for each of these listed elements. I haven't specified if they're going to be cations or anions through the name because I want to see that you can work that out on your own. So I'm listing just the elements, and then you need to be able to write what ion they will form. Calcium, for example, when you look on the periodic table, you see it in the second column, and that tells you that it always forms the +2. So that's the cation, calcium 2+. Try to get the others, pause the video and work them out, and then go on to see if you got them correct. Hopefully your answers match well. Aluminum 3+, nitride is 3-, iodide is I-, and lead, losing 4 electrons, is 4+, and losing 2 electrons is 2+. Those are the two common oxidation states for lead. Now the names and how to name them, I want you to keep track. So for monoatomic ions, remember the cations always just write ion at the end after the name of the element, of the metal, that is. And for the anions, you will change the ending of the original element to be IDE. But what about polyatomic ions? They most commonly end with either ate or ite, and that signifies something very special. When a polyatomic ion ends with either ate or ite, it tells you that they have oxygen attached. So as you look through the list here, you notice that every time one of them ends with ate or ite, so starting at the top, dihydrogen phosphate, ATE at the end, and you see oxygen in the formula. The next one, acetate, ATE at the end, and there's oxygen. Hydrogen sulfate, hydrogen sulfite, and hydrogen carbonate, those all have oxygens. Nitrate, nitrite, those have oxygens. Now you get down to cyanide though. Cyanide doesn't end with ate or ite, it ends with IDE, just like the monoatomic anions did. Okay? But cyanide, you need to know, does not have oxygen, even though it is a polyatomic. So not all polyatomics have oxygen, but when they do have it, they will end with ate or ite. Now, there are more than just what is listed here, but I'm not going to make you worry about those at the moment. However, all of them that I have indicated with the dot here, you need to memorize. Okay? You can write them down in your periodic table, but you will have much better luck throughout the year if you just have them memorized. Because as we go through the year, you're going to have to be able to recognize them in formulas and know that they are polyatomic ions. Polyatomic ions do not separate. They stay together in their polyatomic no matter what's happening in a reaction. So you need to recognize these things when you are trying to predict reactions second semester. Please trust me when I tell you that your life will be easier in this class if you simply memorize these as though they're just vocab that you have to have down. Here you see some space-filling models of some of the most common polyatomic ions, ammonium, NH4+, so it does not end with ate or ite, and there's no oxygen in it. It comes from the compound ammonia, it just has a hydrogen attached. It's one of the very few positive polyatomics that I'm going to want you to know and keep track of. Nitrate, that's one that you're going to have to keep track of, NO3, -1. Sulfate and phosphate, SO4, 2 negative, and PO4, 3 negative, respectively. So polyatomic ions can be positive, they can be negative, they can have -1, -2, or -3, depending on what they have. But you need to just memorize some of these to keep track of them. And in fact, you come across polyatomic ions making up compounds you use in your daily life. On the left here, you see some antacid, which you might have to take now and then. On the right, that's something you probably don't see very frequently around here, but you see crop dusters, and they are applying fertilizers which have nitrates attached to them. So, even though you don't see the crop dusting happening, I'm pretty sure you eat some of the fruits and vegetables that come out as a result of this process taking place. So thank you for watching, ladies and gentlemen. This wraps up part 1 and gives you an introduction to naming mono and polyatomic ions. And in the next video, we will move on and be looking at actually putting them together into compounds. So then you'll be writing and naming the different polyatomic and monatomic ions in ionic compounds. See you next time.